Let's talk about solving linear inequalities. So some properties of just how inequalities work. If you have an inequality, you can add or subtract the same number on both sides. It doesn't change the inequality. So you have a scale, one side is higher than the other. If you add the same amount to both sides, it doesn't change which side is higher and which side is lower. Multiplying or dividing both sides of an inequality by the same positive number doesn't change. So you're kind of taking what's on each side and putting on that same amount repeatedly is still not going to change it. Multiplying or dividing both sides by a negative number. Now, it's a little harder to visualize with a scale. It turns out that it switches the inequality. So that's the important rule to learn that makes solving an inequality different from solving an equation. So solving an inequality, we're looking for all values of the variable for which the statement is true. So there's not going to just be one or two values. There's going to be a whole lot of values. Typically, it's going to be an interval or array or some combination of those. So there's infinitely many actual real numbers that would make that inequality true. We find the end point or endpoints as kind of the significant values, but that doesn't mean that those endpoints, sometimes they aren't even actually solutions. They're just saying this is what we can identify as the first place that it's not true, or sometimes it's the first place where it is true, but the actual solution set is a lot more actual numbers. All right, so the process though for solving the inequality, you can simplify either side of the inequality, you can add or subtract anything on both sides of the inequality, you can multiply or divide both sides by a positive number. So you don't want to multiply both or divide both sides by anything with a variable in it ever with inequalities. But a positive number, multiplying or dividing, the inequality stays the same. Then there's a couple things you can do, but you just have to know that when you do those, you have to switch and reverse the inequality direction. And that's when you switch sides and when you multiply or divide both sides by a negative number. Solving combined inequalities is similar to just solving a regular inequality. It's just now you have three sides, so to speak. So you have to do each step to all three pieces of that inequality rather than just two parts. Some examples as far as that multiplying or dividing both sides by a positive versus negative number. So you don't just switch the inequality automatically if there's a negative number involved in multiplication or division. So if I have 2x less than 4, I divide both sides by 2, all good, no negative numbers involved at all. But if I have 2x less than negative 4, and I divide both sides by that positive 2, there's still no change. So we have x less than 2, this would still be x less than negative 2. If, on the other hand, I have negative 2x less than 4, and divide both sides by a negative 2, now I'm going to switch and have x greater than negative 2. And same thing, negative 2x less than negative 4. When I divide both sides by negative 2, I have to switch and have x greater than positive 2 for that result. So just be careful as far as when to switch or not switch. And then that's the main thing that makes solving inequalities any different from solving regular equations. The other difference is how you give the answer. You may be asked to give inequality form that would probably go into set builder notation. You might be asked for the interval. You might be asked for the graph. With the graph, you'd be choosing from multiple choice. You might be asked for two or all three of those different forms. So you need to be comfortable switching between those, and also just know that when you have that solution to an inequality, that it's representing infinitely many individual values, and it's a completely different thing from just if it was an equal sign and you just had that number or possibly a couple of individual numbers as the solution set. So let's look at some examples, though, of this process. So we're going to solve the inequality. We're going to look at the inequality graph and interval notation forms of the solution. So 3 minus 2x is less than 5. I subtract 3 from both sides. No change to the inequality. Negative 2x is less than 2. But now I need to divide both sides by negative 2. When I do that, the direction of the inequality switches. I now have x is greater than negative 1. So that's the inequality. that would go inside of the set builder. I would then go to the graph. If you don't have the graphs to choose from until after you've done interval notation, draw it out. So the graph, we have wherever -1 is, we're starting there, we're pointing to the right, and we have parentheses because it's greater. So that tells me then the interval is going to be parentheses -1, comma, and then infinity for that right pointing arrow, also with parentheses. So then the next example, we have a little bit more going on. 4x plus 7 is greater than or equal to 2x minus 3. But I can subtract 2x from both sides, no problem there. 2x plus 7 is greater than or equal to -3. Subtract 7 from both sides. 2x is greater than or equal to -10. Divide both sides by 2. Still no need to switch anything. X is greater than or equal to -5. That's the inequality. That's what would go inside, again, of the set builder notation. And then the graph is going to have the arrow pointing to the right because it's x greater than or equal to, square brackets because it's greater than or equal to, and that's at the -5. And so we have square brackets, -5, comma, infinity, parentheses for the interval notation that would just go into an answer box that doesn't have any curly braces anywhere around it. All right, next example, now with a combined inequality. I'm still wanting to isolate x on the part that has x in it, so I'm going to add 2 there, and that means I have to add 2 on the far right and on the far left. I now have -3 is less than 3x is less than 3. And I can now divide all 3 parts by 3. And I get -1 is less than x is less than 1. That's now the inequality that would go inside of the set builder notation. The graph, then, we're going to have parentheses at -1, the other parentheses at +1. The graph is the piece of the number line in between those two. The interval is parentheses -1, comma, +1, close parentheses. All right, next example, we now have -1 less than or equal to, and then we have 3 minus 5x, all of that over 2, and then less than or equal to 9. So I have basically that 3 minus 5x grouped being divided by 2, so I'm going to multiply each part here by 2. So you wouldn't have to necessarily write this out, all the multiplication, but we end up then with -2 less than or equal to 3 minus 5x, because those 2's canceled, less than or equal to 18. Now I can go ahead and subtract 3 from each piece, and I get -5 is less than or equal to -5x is less than or equal to 15. And I'm going to divide everything by -5. And because I'm dividing by a negative, I have to switch the direction of the inequality. So it's now going to be 1 is greater than or equal to x is greater than or equal to -3. Notice if I forgot to switch the inequality, I would have 1 less than or equal to x less than or equal to -3. And that would be a problem because 1 is not less than -3. So that would immediately be wrong. But what I have to do with the 1 is greater than or equal to x is greater than or equal to -3. That's correct, but it's not in the standard format. So I need to rewrite it in the opposite direction. -3 is less than or equal to x is less than or equal to 1. That would then be the correct inequality that would go inside the set builder. On the graph, we have -3, 1, 0, somewhere in between there. Square brackets on the -3 and on the 1, and we have everything in between there. So interval notation, square brackets, -3, comma, 1, square brackets. All right, next example, we have -3 less than 2x minus 1 over 4. less than 0. So similar process here. I'm going to multiply everything by 4. I'm just going to write kind of a multiplication of the whole thing. That's going to distribute then to each part of the equation. So 4 times -3 is -12. On the middle part, the 4 just cancels out the denominator. So I have 2x minus 1. And then 4 times 0 is still 0. Having a 0 doesn't mean there's nothing there. It is still super important, just like any other number. I add 1 on all 3 parts and have -11 less than 2x less than 1, and then divide everything by 2. Because it's +2, nothing needs to switch around. And I have -11 halves less than x less than 1/2. You probably leave it in fraction form. But when you're graphing, then it might be helpful for you to note. So -11 halves is -5.5 or -5.5. So that you can fit that at the right point. So we have like 0, 1, and then the other direction, -1, and it didn't leave enough room. Somewhere over here, -5, -6. And we're going to be in between the -5 and the -6 there with our parentheses. They're at -11 halves and then at +1/2. The other side between 0 and 1. And so you'd look for a graph that does that. The interval notation then would be parentheses, -11 halves, comma, 1/2, close parentheses. All right, and one more example. 2 is less than 2 minus 1/5 x is less than or equal to 3. So I'm going to subtract 2 from all 3 parts of this. I get 0 is less than -1/5 x is less than or equal to 1. And now I'm going to multiply everything by -5. Because that's going to get rid of the -1/5. And because I'm multiplying everything by a negative number, I have to switch the direction of the inequalities. So I now have 0 is greater than x is greater than or equal to -5. So I have to switch that and rewrite as -5 is less than or equal to x, which is less than 0. And that is my final form for the inequality that's going to go inside the set builder notation. Then on the graph, we have 0, and then counting to the left, 1, 2, 3, 4, 5 to -5. Square brackets on -5 because that has a less than or equal to, parentheses on 0 because that part just had a less than, and we have the interval in between there. So the interval notation, square bracket, -5, comma, 0, parentheses. So that's solving linear inequalities.